Hello students, welcome back to our channel. Today we are going to discuss law of chemical combinations. This is the basic concept in chemistry like a class 11, even C4, 6th standard techno students and other basic level, everyone. This is a very important topic, even 9th standard CBSE also. So what is meant by this? Law of chemical combinations. For example, common examples in our day-to-day life we are taking, any chemical changes you are observing, like cooking of rice. What is happening? We are giving some amount of water, then the rice is becoming soft, right? So the chemical reaction is happening. So before using the reactants or after using the after the formation of products, there is no change of that. Okay. So for example, first we will go to the example, then we will come to the law of chemical combinations. What is meant by that? Law of chemical combinations, when you are considering, in that 5 laws are there. 5 laws. Law of chemical combinations, first one, law of conservation of mass, law of multiple proportions, law of definite proportions, and law of reciprocal proportions, and Gay-Lussac's law. And the other one also is there, Avogadro's law. Okay. So Avogadro's law, we no need of discussing about that. So now we will discuss one by one. The first one, law of conservation of mass, was given by the scientist Lavoisier. Lavoisier. Okay. Lavoisier. So what will happen in this law of conservation of mass? Matter, like before starting the reaction and after completion of reaction, the products will be the same, right? There is no change. So matter, we can create matter or we can destroy matter. Like matter neither created nor destroyed during any physical or chemical changes. For example, here I am taking a hydrogen reacting with oxygen, forming as a water molecule. Okay. So to balance this, I am using like this. Okay. Half. So 1 mole of hydrogen reacting with a half mole of oxygen, giving as a water molecule. Okay. So now you take according to the here mass, according to the atomic mass of this one, hydrogen 2 grams. 2 grams of hydrogen is reacting with 16 grams of oxygen. Why I wrote here 16 grams of oxygen? Because here half this 2 will be cancelled, only the single oxygen atom will be there. So 16 will get here and total it is giving us 18 grams. Okay. So now what happened here? The hydrogen we are using 2 grams. Oxygen we are using 16 grams. After the formation of water molecule, weight of the compound will be 18 grams. Okay. So when you are adding these two, 2 plus 16 is equal to 18. So then what we can say? Mass of the reactants is equal to the mass of the products. Is equal to mass of products. Okay. This is what we can say, law of conservation of mass. Matter, here definition, in all chemical and physical changes, the total mass of the substances involved here remains unchanged. You take here, hydrogen is there. Hydrogen is not changing anything even after formation of reacting with oxygen and forming as a water molecule. There is no change. Not only in this, any equation when you are taking, there is no change about that. Okay. And the other definition, matter can neither created nor destroyed during any physical or chemical changes. This is in our hands. Total mass of the reactants is equal to the total mass of the substances after the reaction. The same way here we can say. Okay. So this is what we are explaining about law of conservation of mass. This is also called as law of indestructibility of matter, because we are not able to break it. And we are not this is in our hands actually. If we want, we can create. We don't want, we can destroy. Okay. So example you take here. Like one example, with one example I will explain you here. 2.45 grams of KClO3 on heating gives 1.49 grams of KCl and 0.96 grams of oxygen. So write for this equation first. KClO3 on heating, potassium chlorate on heating, it is going to divide into KCl plus 3O2. 2 KClO3, 2. Okay. And this law of conservation of mass always should follow the stoichiometric equations. because that is should be balanced. The concentration of the amount of the reactants and the amount of the product should be equal in the both the sides. Then only we can say that as a stoichiometric equation. So here potassium chloride on heating it is going to dissociate into potassium chloride and oxygen. So 2 moles of potassium chloride, 2 moles of potassium chloride and 3 moles of oxygen is coming here. So here what they gave? 2.45 grams of potassium chloride. Okay, potassium chloride is dissociating as a 1.49 grams of KCl plus 0.96 grams of KCl. Okay, so according to this you take mass of reactants. How much here? 2.45 grams. And here mass of the products how much? 1.49 of KCl plus oxygen 3 moles. So 0.96. Together when we are considering that will give us 2.45 grams. And we are not able to here balance the equation compulsory. Just we are doing the normal like weight I explained here. Another example you see here. How much amount of sodium chloride is decomposed by 4.9 grams of H2SO4 if 6 grams of sodium bisulfate and 1.825 grams of HCl are produced in the same reaction. So write for this equation first. NaCl sodium chloride plus H2SO4 sulfuric acid gives forming as a sodium bisulfate NaHSO4 plus HCl. Okay, sodium chloride, sulfuric acid, sodium bisulfate, hydrogen chloride. So here when you are taking what is the amount of NaCl, this one we have to find. Okay, this one we have to find. And H2SO4 how much they have given in the problem? 4.9 grams. And here sodium bisulfate how many grams they gave? 6 grams. Okay. Next hydrogen chloride 1.825 grams they gave. Okay. So now you have to find out this. So by using this one, I will erase this. By using according to the law of conservation of mass, what we can say mass of the reactants is equal to the mass of the products, right? So here when we are taking here mass of the products, so you take this one is X plus 4.9 is equal to 6 plus 1.825. Okay. So X plus 4.9 is equal to 7.825. Okay. So X is equal to 7.825 minus 4.9. Then you will get the X value. So like 4.9 when you are taking here 4.9 minus 25 as usual will come 18 minus 9. 7. 18 minus 9. 9. Next here 6. 6 minus 4. 2. So this is the value of X. Okay. So like this we can see. And based on this any reaction you take, any reaction, that reaction compulsory it should follow law of conservation of mass. This is the first one. Next we'll go to the second one. Second one. Law of constant compositions are definite proportions. Any compound you are taking, the availability of the elements, the presence of the element, it should follows a fixed proportion. Then only they are wherever you are taking like hydrogen, carbon, oxygen, any element you are taking that should follows the definite composition. So like this was given by the scientist Proust. So here for example you take a water molecule, H2O is there, water molecule. So here atomicity of hydrogen is 2. So 2 into 1. So hydrogen ratio we are taking and oxygen 1 atom is there. So atomic mass of oxygen is 16. So 2 is to 16 in the sense 1 is to 8. Always this is a fixed ratio wherever you are taking and how many types of reactions you are using. But the ratio of the hydrogen and oxygen should be with like this fixed proportion of weight. This is what we can say. And NaCl, sodium chloride you take. Sodium atomic mass is 23 and chlorine 35.5. Okay. So always this should be with a fixed ratio. More than that it's not possible. Okay. So carbon dioxide you take. For example, the carbon dioxide we can make like 2 methods of carbon dioxide preparation. This is combustion method. First one, carbon plus oxygen is reacting each other, forming as a carbon dioxide. This will say combustion method we can produce. And another carbon dioxide, calcium carbonate, on heating it is going to dissociate into calcium oxide and carbon dioxide. This also we can say. And even methane, marsh gas, reacting with oxygen, forming as a carbon dioxide and 2 moles of water. So you take here carbon dioxide, 3 methods we prepared, here, here and here. In these 3 methods, wherever you are taking, the carbon dioxide compulsory with like carbon atomic mass is 12 and oxygen atomic mass is 2 and here atomicity is 2 into 16, so 32. Okay, so 4 3s, 4 8s. So always wherever you are taking the carbon dioxide molecule, that should follows a fixed proportion of weight, that is 3:8, and water molecule you are taking 1:8. Like this, it has to follow each and every chemical reaction, compulsory chemical compound. So what is the definition we can give here? Chemical substance, the elements are always present in definite proportions by mass. However, the products formed may be. Okay, so this was given by the scientist Proust, and elements combine in a fixed ratio of their atomic weights and atomic masses. Okay, so we have some limitations about this because we know we have an idea about the isotopes. What is meant by isotope? Having the same atomic number but different mass numbers, right? Now, so for example, carbon, when you are taking carbon, 12 isotope is there, carbon 12, carbon 13 and carbon 14 isotopes are there. So for carbon 12 isotope, carbon dioxide always will be with 3:8 ratio. But when you are taking this one is okay, fine, 3:8 ratio you will get it here, carbon and oxygen in case of carbon dioxide. The same carbon dioxide molecule, if you are taking a C14 isotope, what will happen here? C14 means atomic mass of carbon is a 14 here. And atomic, here oxygen is 32, there is no change. So here 2 7s, 2 16, 7:16. So now it is changing, no? So this is not able to explain based on by using the isotopes. This is a one limitation. And the other one, when you are taking the organic compounds like carbon, hydrogen, oxygen. Carbon, hydrogen and oxygen. 3 elements are combining here. And here this is ethyl alcohol. In this compound, ethyl alcohol, 2 compounds, like 2 carbons are there. 2 carbons means 24 and 5 hydrogens are here and 1 is here. So directly I wrote it as a 6 here and oxygen 16. So ethyl alcohol, the ratio of the carbon and oxygen, this one like this. So we can say here 4 6 are even simplest ratio will be like this only. There is no chance of other simplest ratio. The same compound here also, when you are writing the empirical formula, C2H6O. Even for this also, C2H6O, dimethyl ether. So here you take carbon, 2 carbons are there. So 2 carbons, we can write it as a 24, 2 carbons, and oxygens 6 are there. And again, hydrogen 6 are there, 1 oxygen is there. So 16. You can take here 4, 6, like that, wherever you are taking that one, simplest ratio. So, but it is not able to follows the same. So, the ratio will. So, now here the same different compounds with the carbon, hydrogen and oxygen, 3 elements are there. They are forming like a different 2 other compounds, but they are having the same here, same simplest ratio, but they are 2 different compounds. So, these 2 are the limitations of this law. The others, we can say it wherever you are taking, it will come like definite proportions. Okay. So, fixed proportion by weight. Next one, law of multiple proportions. Law of multiple proportions. This was given by the Dalton. Law of multiple proportions was given by the scientist named Dalton. So, name itself we can say multiple proportions, multiple, many. So, like you take carbon monoxide, 1 carbon and 1 oxygen is forming. This is our one compound. And carbon dioxide you take one carbon with the two oxygens. Two different compounds is forming. Even the same thing. Hydrogen and oxygen, both elements are only both two elements are involving. But water molecule and like a hydrogen peroxide, like this. Even nitrogen dioxide, nitrous oxide, dinitrogen dioxide, and dinitrogen trioxide, dinitrogen tetroxide, dinitrogen pentoxide, like this compounds. Like same two elements only are involving to form different compounds. Definition, when you are coming to the definition, when two elements combine to form more than one compound, the several weights of the first element that combines with the fixed weight of the second element, and they are forming like small whole numbers, or different weights of an element combined with a fixed weight of the other element bear a simple numerical ratio. For example, you take here, just I am explaining you, carbon here, atomic mass of carbon 12, and oxygen is only one oxygen, so 16. And here carbon, atomic mass of carbon is 12 and oxygen 2 into 16 when you are taking. So 12:32 ratio. Here you take 4 3s, 4 4s. Here 4 3s, 4 8s. So in this one 3:4. In this one compound 3:8 is the ratio. The same way here you take water molecule 2:16 here. Here 2:32. So here 1:8 we can say simplified ratio. Here 1:16 we can say. Okay. So like this different examples we can say. And nitrogen dioxide you take here. When you are considering to the atomic mass of nitrogen atomic mass N714. Okay. So 2 into 14 we can say. 2 into 14 28 grams. And oxygen 16. So 28 to 16. When you take here, you consider here. So nitrogen 2 and 2O2 here I wrote. Both are same only. So 28 and oxygen 32. And when you are taking here nitrogen trioxide here, nitrogen 28 but oxygen 3 into 16 means that is 48. Next when you take here, nitrogen mass is the same only. 4 into 16. It is coming it as a 64. Next nitrogen as usual same here. 5 into 16 is coming 80. So now when your nitrogen atomic mass is not changing here, the oxygen because of changing the atomic mass of oxygen, we are getting the different compounds by like a simple numerical ratios. When you are considering the oxygen ratio, 16:32:64:80. Okay. So this is what? The multiple proportions. This is what we can say multiple proportions. That's why different weights of an element combined with a fixed weight of the other element bear a simple numerical ratio. Then we can say it as law of multiple proportions. Next one, law of reciprocal proportions. Law of reciprocal proportions was given by the scientist Richard. So first I will explain you the way how it is, then we will go to the definition. So now A, B, two atoms are there. Okay. So these two atoms are involving by using X grams of weight here and Y grams of weight, forming as a AB compound. And the same thing here another compound is there. Okay. Sorry, another atom is there. This is reacting with this by using here Z grams of weight we are using. So these two are also forming as a AC compound, and here also it is forming as a BC using some other weight. Okay. So like this A is reacting with the B forming as a AB compound. This B is reacting with the C as a forming a BC compound. For example, we will take the common like hydrogen, oxygen, sulfur. 3 elements will take. Okay. So hydrogen you take first. Hydrogen is reacting with 2 grams of hydrogen reacting with 32 grams of sulfur. Okay. Forming as a compound H2S, that is a hydrogen sulfide. So once again I am repeating, 2 grams of hydrogen reacting with 32 grams of sulfur, then forming as a compound like hydrogen sulfide as a H2S. The same thing hydrogen, here 2 grams of hydrogen only, reacting with 16 grams of oxygen. Okay, 16 grams of oxygen it is reacting. Oxygen, 16 grams of oxygen, forming as a compound H2O. Okay, so here hydrogen sulfate, hydrogen weight is same. Here also 2 grams, here also 2 grams. And you take here 32 grams of sulfur and 16 grams of oxygen. You take here 32 grams of oxygen forming like a compound, 32 grams of sulfur and 16 grams of this. Okay, so 32 is to 2 into 16, right? 32. So it is forming like 1:1 ratio here. The same thing, you take another compound, sulfur trioxide. This also chances are there. So here 32 plus 48. So now here the ratio 2:3 ratio. So now here when you are finding the same hydrogen, oxygen and sulfur, 3 elements, and these these 2 elements, hydrogen mass is the same, even oxygen atomic mass also same. Thus we are increasing in the volume, number of grams we are increasing. So 16 grams of oxygen here 16 grams, 32 grams of oxygen, and when you are coming to the next sulfur trioxide, 48 grams of oxygen. Okay, so now we will come to the definition. So ratio of weights of 2 elements A and B, which combine separately with a fixed weight of the third element. These two, A and B, are combining with the fixed weight of third element and forming like simple multiple of the ratio of the weights in which A and B combine directly with each other. So A and B is combining directly here. Okay, A and B is combining directly, and then here it is forming the same weight only, here both is there. And again this A is combining with C also can be. Okay, so wherever it is combining, like it follows the equivalent ratios only, the same element, the other element only will give the simple numerical ratios, that we can say. And here this law we can also say it as equivalent reciprocal proportions also. Equivalent proportions, this was given by the Richard. Okay. Now, fifth one, law of Gay-Lussac's law, or we can say law of combining volumes. This is especially for gaseous molecules we are saying. So, when gases react, the volumes of the reactants and the productants are in the same ratios that are provided in the volumes that are measured at the same temperature and pressure. For example, you take here hydrogen is there reacting with the chlorine, forming as a hydrogen chloride. So 2 moles. So what we can say here, all are gases only here. So 1 volume here, 1 volume of hydrogen reacting with 1 volume of chlorine, giving as a 2 volumes of hydrogen chloride based on the stoichiometry. So now what it is, 1:2 ratio it is forming. You take like a water molecule, hydrogen is reacting with oxygen, forming as a water molecule. Okay, so here we can say H2 plus O2, hydrogen and oxygen, giving as a 2 moles of water. Like here 2 moles of water. Okay, so 2 volumes here we can say, 1 volume of oxygen, giving it as a 2 volumes. So even nitrogen, you take nitrogen plus oxygen gives nitrogen 2 then O2. So here also. So when you are taking here 1:2:2, simple numerical ratio. So any gases when you are taking, gases are reacting like combining volumes. Gases will form a simple numerical ratio. This is what about the Gay-Lussac's law, and he gave about the same temperature and pressure at STP conditions. Standard temperature and pressure, he explained about Gay-Lussac's law of combining volumes. Thank you.